Hey guys, in this video I'm going to show you how to draw the Lewis dot structure for bromine pentafluoride. So here we go. So bromine pentafluoride BrF5, that's going to give us 7 valence electrons from the bromine plus 5 fluorines, each with 7 valence electrons as well, for a total of 42 valence electrons. Okay, we can subtract out the largest multiple of 8, which is going to be 40 in this case. That gives you 2 remaining electrons. Divide that by 2, gives you 1 non-bonding pair, and 40 is equal to 8 times 5. So that means that this structure will be an AX5 E1, so central atom, 5 peripheral atoms, and 1 non-bonding pair of electrons on the central atom. Alright, so let's go ahead and draw this structure, okay? So you're going to have the bromine in the center, surrounded by the 5 fluorines. Okay, we can go ahead and single bond all of the fluorines to the bromine in the center, and then also fill in the octets for each of the fluorines. Okay, so now each fluorine has 8 electrons, but we still have to put in this non-bonding pair of electrons on the bromine in the center, so we'll just stick that right in there, and that is actually going to be our final structure. Let's go ahead and check the formal charges just to verify. So the formal charge on the bromine is going to be 7 valence brought in minus 1, 2, 3, 4, 5 bonds minus 1, 2 non-bonding electrons, for a formal charge of 0, and then the formal charge on each of the fluorines, and they're all going to be the same because they all have the same setup, so we can just calculate it once. It's going to be the 7 valence electrons are brought in for each one, minus a single bond for each fluorine, minus 2, 4, 6 non-bonding electrons for each fluorine as well, for a formal charge of 0. Multiply that times 5, because there are 5 of those fluorines. Still going to be 0, but still have to multiply. Add all these up, it's going to give you a formal charge of 0 overall for the entire structure, meaning that it matches up because this is a non-charged particle. So those are supposed to match, so that's what we're looking for. Okay. Now in terms of shape, with the AX5E1 type of structure, that is going to be a square pyramidal type of structure, okay? And then when you have those kind of structures, the bond angles are going to be approximately 90 degrees, all right? Because it's a triangle, or sorry, a pyramid with a square base. You have these 4 fluorines are going to be the corners of the square base. This is going to be above the square, and this non-bonding pair would be below the square, okay? And in terms of hybridization, looking at the central atom here of the bromine, there's 1, 2, 3, 4, 5, 6 electron groups. So we're going to need 6 orbitals. So sp3d2, so 1 s, 3 p's, and 2 d's. So sp3d2 hybrid. Okay, and due to the fact that we have this non-bonding electron pair right here, that is going to make this a polar compound. Alright, that is pretty much it for this one. If you have any questions, please let me know, and thank you for watching.